Have you ever wondered what happens when an acid reacts with a base? This intriguing dance of substances is known as neutralization, a process where two seemingly opposing elements come together to create something entirely new. Now let's dive into this exciting world of chemical reactions. Neutralization at its core is a reaction between an acid and a base. It's like a chemical tango where each partner plays a crucial role. The acid, with its surplus of hydrogen ions, and the base, overflowing with hydroxide ions, dance together, reacting to create two completely new products. And what might these be, you ask? Well, they're none other than water and salt. But that's not all. This chemical rendezvous also results in the evolution of heat, adding a fiery twist to the mix. It's a little bit like a chemistry love story, isn't it? So, when an acid and base react, they neutralize each other, forming salt and water. But how does this process work? Keep listening to find out. To understand neutralization, you need to know a bit about what acids and bases are. Now let's dive right into it. Acids, in the simplest terms, are substances that have a penchant for donating hydrogen ions, represented by H+. They're like the generous folks at a party, always ready to give something away. On the other side of the equation, we have bases. Bases are the opposite of acids in this scenario. They're more like the guests at the party who are always ready to accept what's being offered. In this case, that's the hydrogen ions. Now imagine a party where these two types of guests meet, the acids and the bases. What do you think will happen? You guessed it. The acids will start giving away their hydrogen ions, and the bases will start accepting them. This is where the magic of chemistry happens. The exchange of hydrogen ions between acids and bases is the crux of what we call a neutralization reaction. But wait, there's more. The story doesn't end with the mere transfer of hydrogen ions. As the hydrogen ions from the acid get cozy with the bases, they combine in a way that results in the formation of water. Yes, you heard it right. The very water you drink is a product of this fantastic chemical reaction. However, our acid and base aren't satisfied with just creating water. They go a step further and combine to form another compound that we commonly refer to as salt. So, the next time you're enjoying your salty chips, remember, a neutralization reaction might have played a part in bringing that flavor to your palate. So, there you have it. That's the secret behind neutralization, the exchange of hydrogen ions. But what does this look like in real life? Let's move on to some common examples. Neutralization reactions are more common than you might think. Let's dive into some everyday examples, shall we? First up, let's talk about something we've all experienced: heartburn. Our stomach contains hydrochloric acid, which helps us digest food, but too much of it, and we're left with a burning sensation. This is where antacids come into play. These are basic substances that, when swallowed, react with the excess acid in our stomachs, neutralizing it and providing us with much-needed relief. Next, let's consider a bee sting. Quite unpleasant, isn't it? The sting injects an acidic venom into our skin, causing pain and swelling. But applying a basic substance like baking soda can help. The baking soda neutralizes the acidic venom, reducing the pain and swelling. So as you can see, neutralization is not just a lab experiment, it's a part of our everyday life. But why is it important? The process of neutralization has significant implications. In a world where balance is key, neutralization plays a crucial role in several fields. Let's take a look at a few. In agriculture, neutralization is a farmer's best friend. It helps maintain the right soil pH, enabling crops to grow healthily. Without it, soil could become too acidic or too alkaline, making it difficult for plants to absorb nutrients. In the realm of medicine, neutralization comes to our rescue when we experience heartburn or indigestion. Antacids, like the ones we may have in our medicine cabinets, work by neutralizing excess stomach acid, providing relief. Over to environmental science, neutralization helps keep our environment safe. It aids in neutralizing acidic pollutants, preventing them from causing harm to wildlife and ecosystems. So the next time you see an acid and a base, remember they do more than just react. They neutralize each other, creating a balance that's vital to our world.